Hi, good evening. I bid to Dr. Nordin and all of my friends. So today I would like to give a presentation of our assignments for fluid mechanics. My name is Atira binti Azmi. My matrix number is 199208. Okay, so let's get started. So the first slide is the fluid characteristic. So firstly, what is fluid? Fluid is a substance that has no fixed shape and yields easily to external pressure. Fluid is divided into two, which is liquid and gas. So we'll see the characteristic of liquid. Liquid has definite volume but indefinite shape. Their molecules move slower and collide more. It has higher pressure. So the gas, it is easy to compress. It expands to fill their containers. It occupies far more space than the liquids or solids from which they form. Okay, so the important characteristic of fluid from the viewpoint of fluid mechanics are density, pressure, viscosity, surface tension, specific gravity, and specific weight. When a shear stress is applied to a fluid, it experiences a continuing and a permanent distortion. Fluids offer no permanent resistance to shearing and they have elastic properties only under direct compression. All in all, fluids can be defined unambiguously as a material that deforms continuously and permanently under the application of a shearing stress, no matter how small. Okay, next is dimensional analysis. So what is dimensional analysis? It means of simplifying a physical problems by appealing to dimensional homogeneity to reduce the number of relevant variables. Analysis of the relationships between the different physical quantities by identifying their base quantities, such as length, mass, time, and electric charge. Any physically meaningful equations and any inequality will have the same dimension on its left and right. It is a property known as dimensional homogeneity. So, let's see the basic rule of dimensional analysis. First, it is only commensurable quantities, which is the physical quantities having the same dimension. It may be compared, equated, added, or subtracted. Second, one may take ratios of incommensurable quantities, which is quantities with different dimensions, and multiply or divide them. The fundamental dimensions is m, l, and t. Okay, so there are two methods of solving dimensional analysis. So the first method, so we'll see here the two methods are Rayleigh method and Buckingham's pi theorem. So I'm going to explain for the first method, which is the Rayleigh method. It expresses a functional relationship of some variables in the form of an exponential equation. So we'll get to the example. So problem 1. Drag force is a function of velocity, mass density, viscosity, and diameter of sphere for fluid flow. Use dimensional analysis to determine an expression relating these variables using Rayleigh's method. So the solutions I'll explain one by one. So the first thing first is you write out the dimensions for each variable. So the drag force equals to ml over t squared, v equals to l over t, rho equals to m over l cubed, u equals to m over lt, and d, which is the diameter, equals to l. So we write the equation like this. So fd equals to k, which is just a constant. So v to the power of a, rho to the power of b, u to the power of c, and d to the power of d. So we'll insert the dimensions for each. So ml over t squared and k is just a constant. So l over t to the power of a, m over l cubed to the power of b, m over lt to the power of c, l to the power of d. So from previous equations, we can solve for the m, l, and t. So m 1 equals to b plus c, l equals to 1 equals to a minus 3b minus c plus d, t equals to negative 2 equals to negative a minus c. So we have three variables and four unknowns. Three dimension variables, which is MLT, and four unknown, which is A, B, C, D. So we will insert So fd equals to k v to the power of a, which is 2 minus c, rho to the power of p, which is 1 minus c, u to the power of c, which is c, and d to the power of d, which is 2 minus c. So you cancel out everything and you'll get something like this. So this is to the power of c. Okay, but then it is this is exactly the answer. But then it is important to check to see if our terms are dimensionless. Then it is correct. So how to check? So we have to make sure that the left side and the right side are both dimensionless. So we'll insert the dimension for each side. So for the left side, we'll cancel out everything and we'll get 1. So for the right side, we cancel out everything and we'll get 1 too. So both sides is dimensionless, so it is correct. So let's move on to the Buckingham's pi theorem. This method allows to relate things in terms of dimensionless parameters. Example, problem 1. A small pebble is dropped into a liquid. When this happens, small waves travel outwards. So we write the variables c equals to f rho, lambda, h, and alpha. So they have 5 variables and 3 reference dimensions, as you can see here. So variables will minus reference dimension. So 5 minus 3, so we have 2 pi group. So the repeating variables are h, rho, and alpha. So for pi 1, so we'll choose c, h, rho, and alpha. So we'll insert the dimensions for each and also the power of each dimension. So we'll get something like this, equals to m to the power of 0, l to the power of 0, and t to the power of 0. So we'll solve MLT. So we'll get t equals to negative 1 minus 2c equals to 0. So c equals to negative half. M equals to b plus c equals to 0. So b becomes half. So L equals to 1 plus a minus 3b equals to 0. So a equals to half. So pi 1, we'll insert everything based on the what you get on ABC. So we'll get something like this. Okay, so let's move on to the pi 2. Pi 2 we have rho, lambda, h, and alpha. So we'll insert the dimensions for each of the variables. So once we insert, equals it with m to the power of 0, l to the power of 0, and t to the power of 0. So from this equation, when we solve um, for a, b, c, we'll get something like this. So c is to the power of 0, uh, c is equals to 0, b is also equals to 0, and a is equals to negative 1. So pi 2 equals to lambda over h, as we have cancelled out everything. So it will be like something like this. So this is the answer. So that's all from me. Thank you.